Hello, this is Ray, and we're going to do a separable differential equations problem. All right, here's our problem, and if we know that it is separable, the first thing we want to do is we want to rewrite our y prime into a dy dx so that we can see things actually separate. So we'll have dy dx 1 plus x squared, and let's go ahead and move this xy over to the other side so we have equals negative xy. And then from here we can separate things. We'll combine all the dy's. There's a y on the right side. We'll divide out. And then we have a negative x, and we'll divide out a 1 plus x squared, and then we'll also have a dx sitting there for us. And we will integrate both sides. And let's see, on the left hand side it looks like it's going to be an ln of y, and on the right hand side u substitution, maybe we'll do that off to the side here. U equals 1 plus x squared, du is going to be 2x dx. So there's an x here, there's a dx there, so there's a 2 and a negative, so we have a negative 1/2 integral 1 over u du, which is going to be the ln of u. So that's what we get. On the right hand side we get a negative 1/2 ln of u, but u was equal to 1 plus x squared. And then we'll throw the plus c in here. We can note that x squared is always going to be positive, and we add 1 to it, then it's always going to be positive, so we don't need the absolute value on that side. And then we probably want to rewrite this as a ln of 1 plus x squared to the negative 1/2 power plus c, so that we can take the ln of both sides. If we do take the ln of both sides, we're going to get y equals e to the ln of 1 plus x squared to the negative 1/2 power plus c. Now the plus c here can be written as e to the c that's being multiplied with a whole exponential function. So we'll treat this and maybe just call that a. So your general solution, y is equal to a times 1 plus x squared to the negative 1/2 power. Okay, I suppose we can just go ahead and rewrite that as a divided by the square root of 1 plus x squared. All right, so if we're interested in looking at this between x values between negative 2 and 2 and y values between negative 1 and 1, we can take a look at a slope field of that. I already drew the slope field here, and it looks like we got these values. Let's graph our solution, y equals, and then we have an arbitrary a divided by the square root of 1 plus x squared. And then if we throw in a slider a for different values of a, we're going to get different solutions. And if we take a look at the solution and any point on the solution, we'll see that we're going to get the slope field to be, well, tangent to these things. As a gets larger and larger, we see the point also is going to remain tangent. So if you had an initial condition, say your initial condition was 2 comma 1, let's say 2 comma 1, we're right here at the point 2 comma 1, we can find the a value so that the curve is going to be tangent at that point. So a is about 2.3. That's not precise, but it looks like it's kind of close enough, and we would do our analysis on paper if we were going to continue doing that. Okay. All right, so that is our solution for our differential equation, and general solution for our differential equation. Good luck.